Good morning, good evening, and welcome to this panel discussion on production and sourcing of green hydrogen. My name is Walter de Wit. As Karen just said, I'm the Innovation Attache at the Consulate General here in San Francisco. Also, welcome to all the Dutch, US, and Canadian participants in this session. And of course, a very big thank you to our great panel, Nicole, Michel, Afkenel, Joost, and Jason. We are going to do five-minute pitches. After each two pitches, there will be a very short Q&A. If you have questions, please send them through the Mentor Jam forum. And now we are going to start by having all participants in this panel discussion very briefly introduce themselves. And very briefly is like 30 seconds. Can I start with Nicole?
Yeah, sure. So hi, thanks for having me here. It's a pleasure to be part of this. So my name is Nicole Vermeulen. I'm working for Shell and I'm based in The Hague, the Netherlands. And to introduce myself, I'm an outdoor sports lover. I really like kite surfing, and I guess that the wind as an energy force has therefore intrigued me to focus on renewable energy early on. So I have about 17 years of experience in various commercial roles and in different industries. I spent nearly half the time abroad. Joined Shell about 8 years ago in the Netherlands, and currently I'm responsible for all the contractor and procurement related to green hydrogen. I work, for example, on the Rotterdam Electrolyzer project, which I will share more about later on.
Thank you very much, Nicole. Jason.
Hi, Jason Holt. I'm with a family office in San Francisco called Baruch Future Ventures that invests in the resources and climate space. And hydrogen is a relatively recent area that we've taken an interest in and looking to make a series of investments in. So I'll give more information on that when my slides come up.
Looking forward to that, Jason. Joost, can I ask you to introduce yourself?
Yes, thank you. I'm Joost Sandberg. I'm working for Nouryon, the specialty chemicals company with electrochemical experience, as you see behind me. I am responsible for business development in the green hydrogen and circular chemistry sphere.
Thank you, Joost. What I see behind you looks very impressive, by the way.
200 megawatts.
Michel, could you introduce yourself?
Hey, good afternoon. Michel Archambault from Cummins. I'm from Canada, based in Montreal, responsible for development of hydrogen opportunities, especially in the production side in North America and South America as well. Very quickly, I've worked on the projects that you've seen and will discuss in Quebec, as well as other large production facilities in the US. Happy to be here today. I'm a very old person in the hydrogen world with 20 years of experience, but it's picking up and it's very exciting times.
Thank you, Michel. Afkenel.
Thanks very much, and good morning, good afternoon. That's very impressive, Michel. Can't say that I've got 20 years of experience in the hydrogen business. I do have some experience in the hydrogen business, and I'm currently the Senior Vice President Business Development for ENGIE, and responsible for a large-scale hydrogen project in the Netherlands, which I'll talk more about after.
Thank you very much, and great to hear that there's so much experience in this panel group. Please don't forget to everyone listening in, watching, please, your questions that you have through the Mentor Jam forum. So we'll have time to go through the questions at the end of the 5 different presentations. Nicole, I would like to give you the word and give you the 5-minute presentation on behalf of Shell.
Okay, good.
Thanks.
So I cannot see if the slides are already up. Yes. So thank you for that. So we can move to the next slide, please. And you keep on clicking. Yes, thanks for that. So let me first share some high-level introduction about Shell and the energy transition. So Shell has set itself the ambition to become a net zero emissions energy business by 2050, and sooner if possible. And we aim to do that in line with the society's progress towards the goal of the Paris Agreement. And that means that our business plans have to change over time to be in line and matching with the society and the customers' needs and preferences. So why is Shell actually looking at hydrogen now? So there's a number of factors that are changing in the energy sector that have made that happen. So first of all, it's the climate change and the air pollution, increased demand for clean energy and transportation, and increasingly commercial technology available and a price decrease of the green electricity that has happened now. And the new supportive policies, which are actually essential for us to make this even economically viable. Shell has been working in the hydrogen industry for the past decade already, and we have gained some experience and built relationships over the years that we believe will now enable us to play our part in making hydrogen a key energy solution around the world. So we do see opportunities across the full breadth of the hydrogen supply chain, so including the production, the storage, the shipping of the hydrogen, as well as the end customer sales. And I think the advantage of Shell is that we are part of this full value chain. But obviously Shell cannot do this on its own, so it needs to be achieved together with its partners and as well with the policy makers. So we're currently working on various projects to scale up in the green hydrogen production. And at the same time, we also do quite a lot of research and development from our R&D department, for example, in Amsterdam. So if we move to the next slide, I will give you an overview of the projects that we are currently working on. Yes, thank you. So first of all, it's our Rhineland project. So that is the Refine project in Germany, in the Shell Rhineland refinery in Wesseling. And where we've started the construction of the largest PEM electrolyzer, one of the largest in the world at this moment. And the green hydrogen will be produced for the use in the hydrogen itself, and potentially later on for other customers. And this electrolyzer will have a peak capacity of approximately 10 megawatts and will produce approximately 1,300 tons of hydrogen per year. And then we have the MNGZI, and in Emmen we also intend to build a 10 megawatt electrolyzer plant, and that is going to be on the location where we used to have our own gas facilities. But the difference here from Rhineland is that the green hydrogen will most likely be used to service the local industry in the Emmen region. And then thirdly, we are actively developing now an integrated green hydrogen hub in Rotterdam. So you've heard more about that yesterday and the day before. From the port of Rotterdam, so I will tell you a little bit more in a minute about that. But here we want to build a 200 megawatt plant by 2023. And then fourthly, it's the big ambition that we have with North H2, and that's to build a 4 gigawatt to 10 gigawatt plant in the north of the Netherlands. So you might have seen some announcements about that as well in the last 2 days with new partner announcements there. And besides these projects, we're also still looking at other locations like Hamburg in Germany and other R&D projects that we're quite actively seeking for new technologies and to see how we can make them upscale for the future. So if you want to move to the next slide, I will go a bit further into the Rotterdam project. So together with our partners, we want to create a green hydrogen hub in the port of Rotterdam. And Shell aims to produce the green hydrogen on the Tweede Maasvlakte, where we will be using green electricity from wind power. And this wind power is intended to come from the offshore wind farm Hollandse Kust Noord. And that wind farm is intended to be operational by 2023. So green hydrogen can play an important role in the decarbonization of the industry, which currently uses large volumes of gray hydrogen. So in replacing this hydrogen produced from natural gas with green hydrogen, that contributes to the decarbonization of the energy system. And a second important use will be the heavy-duty transport. So if it all goes to plan, then the hydrogen plant on the Tweede Maasvlakte will be built on the site, which is specifically designed by the Port of Rotterdam. And that is the 2 gigawatt conversion park, which was also presented yesterday by Allard of the Port of Rotterdam. And in this plant, the green hydrogen will be produced through electrolysis, and it will be with a capacity of around 200 megawatts. And we intend to start operation as well by 2023, so when also the offshore wind farm comes on stream. And it should produce then around 50,000 to 60,000 kilos of hydrogen per day. And initially we will use that in our own refinery, so that is Pernis in Rotterdam. And later on, hopefully also to mobility. So a project like this has obviously many challenges, and that was also earlier mentioned by Leonard. and that is to go for the upscaling within this given time frame until 2023. As at this moment, the supply chain still needs to be developed, and as not such a large-scale project has been built yet. So currently we're working really closely with the market and with a few electrolyzer manufacturers to assess and to de-risk the technology solutions for our Rotterdam project to build it up to 200 megawatts. And with a few of these manufacturers, we are now working on engineering designs, and we intend to select the best design next year with the best ability to deliver. And it should also meet our timeline, obviously. So we intend to take the final investment decision about this next year as well. So I will leave it to this for now, but obviously if there's more questions, I'm happy to answer them. And also, of course, later on offline, feel free to connect with me.
Thank you very much, Nicole. One or two very quick questions about what you said. You started saying why hydrogen now, and you gave a couple of very good examples as to the why now. What is the why now in the money making part? Could you tell us a little bit more about that? How do you see that in a timeline for the coming years?
No, I think that's an excellent question, and I think, as we all know, that the green hydrogen is not yet economically there. So we definitely need to have the policymakers on the same side as well, and subsidies are still important in order to achieve this. While in the same time, we are working closely with for example, the electrolyzer vendors to see how we can improve cost efficiency as well in the plant itself.
Thank you. And I did read recently, I think it was announced like a month ago, that Morocco and Germany are entering into a partnership to develop green hydrogen. Is Shell also looking into these kind of international partnerships?
Yes, we're also looking internationally. We are, for example, we are working with Germany as well, but I cannot give you any further examples at this stage yet.
Germany it is? Okay, we have more questions for you later. The first we go to the next speaker, Afkenel. Can I ask you to unmute and start whenever you're ready?
Yeah, I am. Thanks again, Walter, and good morning and good evening again. I hope you're enjoying this hydrogen mission so far, and it's great to actually be in California and British Columbia and the Netherlands at the same time. Although I guess at this point I wouldn't have minded some travel, but we'll have to bear with that. So again, my name is Afkenel. I'm Senior Vice President Business Development for ENGIE Hydrogen, and I'm responsible for the HyNetherlands project, which is a large-scale green hydrogen value chain in the northern Netherlands. You probably have heard a lot about these developments in the northern Netherlands, and that's because gas infrastructure is very large there, because the Groningen gas field was produced there. So a little bit about ENGIE. ENGIE is a French electric utilities company. We employ 160,000 people, so it's pretty
Jason?
sizable.
Twee achter elkaar en dan de break, hè?
Sorry, you're mixing the sound. Yeah, okay, that's good. Thanks very much. So what I think is very interesting about ENGIE, and I just joined the group a couple of months ago, is the fact that they really see the future as being green. And to underline the strategy, they, for example, divested their coal-fired power plants and the oil and gas exploration and production activities. I'm not saying that these are bad activities or anything, but it does show a focus on the strategy. So for hydrogen, we are developing projects in Chile, in South America, in South Africa. These are mostly related to the mining industry, so it's usually off-grid solutions. There is a project in Australia linked to the ammonia industry, again off-grid, so very interesting. And these locations are interesting in terms of solar PV because of their efficiency. And then there's Europe, of course. There's mobility and industry projects. And quite recently, we are working on some prospects in the US at this moment. So it's truly a global business. So one of the areas of interest is, of course, the Netherlands, the Groningen area, which I mentioned. And a lot of things that Nicole already mentioned are not going to be very different for our project. The green hydrogen market has not been yet developed, so we're really looking at creating the value chain, working in partnerships with a series of off-takers, but also making use of the favorable context in the Netherlands right now, which supports the green hydrogen development, but also supports the region of Groningen, which is transitioning from a fossil-based industry to a greener green hydrogen-based industry. So the project specifically is based on a stepwise approach with progressive commitments. We start with 100 megawatt of electrolysis. I hope to take an FID end of next year. I say I, but of course this is the group finally deciding on this, but I'm working very hard towards that. And then the construction will start, and we hope to start producing green hydrogen in Q2 2024. So this will be at ENGIE's Ames power plant. This is quite a unique location because there's the extensive gas network, which will be converted into a hydrogen network. Then there is a large chemical industry over there. So that's for the off-takers. And there's also the landing of offshore wind, and there are various grid connections to other renewable power sources. So the off-takers that we're looking at is in the chemical industry, but steel, for example, as well, and the heavy-duty transport. And it was just mentioned previously about the liquid hydrogen route. We're looking at this as well, and we've just started a cooperation with the Ariane group. This is a aerospace industry group. It's a joint venture between Safran and Airbus. So you will recognize a lot of French names here. And together we try to really reduce costs in liquefying hydrogen. I mean, ballpark, you can say that it costs €2 per kilo right now, and we want to basically halve that. Sorry, I'm lost for words now. I'm so impressed by my own projects. No, that's not true. I guess I just want to repeat, and of course the nicest part of discussions like this are always the interaction. So I'm really looking forward to questions. Please reach out to me via email or LinkedIn as well. If you have any questions, I can very well summarize the project and tell what is on my Christmas wish list. There is, of course, the infrastructure that has to be there, the potential off-takers. There has to be support from the government, but also in the regulatory aspects and in terms of regulations. The technology hopefully will improve further. And I think, well, I'm not saying this is the easiest part, but probably something that I have big trust in, because the sort of OEMs are really working hard on this. And lastly, of course, we need enough green renewables. So thanks very much, and look forward to your questions.
Thank you very much, Afkenel, and an impressive wish list that you have there for the coming years. Before we
I never said it was easy.
Before we go to the Q&A, first we would like to go to the presentation of Jason Holt. Sure. Jason, are you ready to go?
Yep.
Great.
Let's see. Just trying to see if I have controls here. Okay, got it. Okay. Well, before I talk about this slide, maybe just backing up, I'll give you a background on our group. I'd say for sure, hearing the backgrounds of everyone thus far, we're certainly the least experienced in the hydrogen space, but pretty excited about its potential for reasons that'll become obvious. But Baruch Future Ventures is a family office that does early stage investments in resource tech companies that can positively impact climate. And it was founded by my colleague Tom Baruch back in 2012, who was a veteran of the venture capital industry. He founded the first VC firm to really focus on investments in the chemical materials and energy sector called CMEA back in the late 80s. And a quick background on me, I've been in R&D for a number of years, worked at a local national lab here in the San Francisco Bay Area, Lawrence Livermore Labs, working on a variety of projects in energy and water purification and the like, and then started subsequent to that experience, started a couple of companies, one in the water treatment space, another in the building tech space, and because of our kind of combined operating and investing experiences collectively, we like to work at the earliest stages of companies, often at their founding, where we think we have a chance to really steer them in the right direction, help them build out their team, and develop the right go-to-market strategy. So to jump to the next slide and give you a bit more information on our investment themes and how this all ties into the topic of this panel. So we take a very thematic approach to our investing and look at all of the technology trends and the markets that can be the biggest levers on climate and create the biggest CO2 impact. And I think the really interesting part here is that green hydrogen, the subject of this panel, relates to all of the themes on the left in one way or the other, and that's part of the reason why we've become so interested in this space. And it's really just in the last year that we spent a lot of time doing a deep dive on it. And I can cite a few examples. Synthetic biology is one key thematic area for us, and for those not well versed in it, it's all about using microorganisms, whether native or genetically modified, to make products better, faster, cheaper, and greener. And hydrogen can be a key feedstock chemical for that, a reductant that can be used in many of the fermentation processes that are used in the field. New mobility, is I think that one probably speaks for itself. Hydrogen is a lot of the previous talks have emphasized. It's I think a key to greening our transportation sector. I think we're not like many, not as bullish about the potential in passenger vehicles, but certainly in long haul transport and short to medium range aviation. We think there's a lot of potential there, and also in using green hydrogen to make other chemicals downstream of that. Green ammonia, as an example, that could be used as a marine fuel. And the other two themes here, the fourth and fifth that we list on our on this slide here, decarbonization and free electricity. Those really kind of go hand in hand. By using cheap green renewables, we can make green hydrogen, which in turn is the starting point for making a whole series of products with much lower carbon footprint. And I think the thing that we find really remarkable is what's happened with solar energy in the last decade or so. The Moore's law like decline in prices for solar is now going to allow us to do things that we couldn't have envisioned even 5 years ago in reducing our collective greenhouse gas footprint. If you move to the last slide here, these are just a couple of our perspectives on the sector. I think given the level of expertise on this panel, none of these things are going to be earth-shattering or controversial, but I'll walk through them in any case. And hydrogen, from our perspective, is really the linchpin chemical that can allow us to decarbonize industries that have enormous GHG footprints. And steel making is a good example. With a process like DRI, direct reduction of iron, we've actually made an investment in a very early stage company that's not exactly doing DRI, but which can capitalize on cheap green electricity in the steelmaking process. And when we kicked off our research into the space, we actually looked at a variety of different routes to producing hydrogen, including things like methane pyrolysis, which I think was alluded to on a previous panel. Even geologic hydrogen. But I think the conclusion we quickly came to is most of these alternatives fail either on economic grounds or on scalability, for scalability purposes. So from our vantage point, electrolysis is obviously the logical technology to back. And in terms of techno-economic targets, the things that really interest us most, in an early stage startup in this space, is to see that they have line of sight to getting to $1 per kilo or less. Whatever the technology would be, I think we're agnostic to the specifics of whether it's PEM or alkaline electrolyzers used, or potentially some other flavor of electrolysis. But for us, $1 a kilo is really the interesting number, because that's what can beat SMR in virtually all markets, even in the absence of a strong CO2 incentive or taxation. But as a stepping stone, for some of these companies, $2 could still be interesting in some markets, particularly in Europe and Asia, where natural gas prices are higher. And the last point I'd mention is that we're interested in hydrogen, as I alluded to earlier, really as the stepping stone for making other green liquids, ammonia as an example, as I mentioned, for either direct combustion as a marine fuel, or simply as a hydrogen carrier. And we just saw in the last week or two some interesting work out of Northwestern University to show electrochemical conversion of ammonia back into hydrogen. So it's very early stage work. The techno-economics, I think, haven't been worked out yet, but I think these are the kinds of technologies that are of interest to us, and in really building out the green hydrogen space. So I'll stop there.
Jason, definitely some questions for the two of you. Also questions from the audience. Jason, traditionally, green hydrogen, a world of many subsidies. Are there enough VC funds around to really invest in hydrogen from the VC perspective?
We think so. There could be more, certainly, but one group that we closely partner with, and my colleague Tom is a senior advisor to, and on their scientific panel, is Breakthrough Energy Ventures. They've got over $1 billion to deploy in this space, and I think they're very public about the fact that hydrogen is a key to decarbonizing some of these industries that I mentioned. So I think they are the highest profile example, and the largest, I think, pool of capital that's been put together to date for investments in sectors like this. And I think there's some strong signals that there are going to be a number of other funds trying to do the same here in the coming years. And I think with the change of administration too, I think that's going to give a big push to get some of these other larger pools of capital together to invest in the space, because it's starting to feel like a real movement now. So I'm somewhat optimistic about the potential for more capital, more venture capital in the sector.
That sounds great, Jason. And very good that you also answered one of the follow-up questions. It was the new administration and how that might affect funding. Good to hear that there's going to be more available in the coming years. Afkenel, a question that came in for you. Focusing on the consumers, how much consumption of green hydrogen is expected in the coming years?
I'd love to know as well. But that's not a very nice answer. Of course, we've done our modeling, and that is, we start with 100 megawatt per year, and then we stepwise increase it with the growing consumption as well. So it's just very, very hard to predict, because initially we're really focusing on the chemical industry, because that's where it could be replacing gray hydrogen. but we now see that the mobility sector is moving quite fast, and then specifically the heavy mobility. And the price differential is just a bit smaller there, so that might be a very interesting market as well. I can share some numbers, but it's yeah, sometimes it's just very hard to predict the future in that way. But I guess one interesting thing to mention is that via this infrastructure, or this hydrogen infrastructure that I mentioned that is being developed, a large part of it is already existing in the Netherlands. So it's the currently existing natural gas network, but it can easily be refitted to transport hydrogen. And via this network, you can connect all the different industrial areas, but also really easily connect to Germany and Belgium, for example, so the neighboring countries. And that really will make the market much more liquid.
Thanks. Thanks. One more question for the both of you. Jason, you first, also from the audience. Are you currently outperforming the market?
Outperforming the market, yeah. I think relative to other investors, that admittedly there aren't that many that invest as early as we do, but I think we were looking at this quite recently, and without providing specific numbers, I think for a seed stage firm that takes on as much risk as we do, I think we're probably in the top decile of the admittedly small number of firms that do what we do. So we're pretty happy with that.
All right, that sounds good. Good return on investment then. Afkenel, we heard that you are one of the founders of Women in Energy. The audience would definitely like to learn a little bit more about what it is. You have a founding role in that one. Could you tell us a little bit more?
Yeah, of course. It's not rocket science. There are not that many women in the oil and gas industry, in the energy sector. I'm really happy that this panel actually shows two. I'm usually the only female on a panel, and I'm sure Nicole can sort of confirm that as well. So we wanted to make women a little bit more visible and also network together. And I truly, truly believe that diverse teams perform better, and that diverse teams also accelerate innovation. That's exactly what we need in the energy transition. So it's really simple. Why would you only use half of the human capital, and where you can actually use the complete population?
Thank you very much.
That's my soapbox for the moment. But I'm really sort of invested in this because, of course, my real goal is to really accelerate the energy transition.
Yeah. All right, thank you. We'll continue with the next two speakers. Joost, are you ready to do your presentation?
Yes, I am. Thank you, Rob, and thank you all for having the opportunity to introduce Nouryon's green hydrogen chemistry to you. We'll look to the Paris Accord on also the next slide. As a chemical company, we've looked at the role that we can play in a decarbonized world in 2050. And I think what already is mentioned is the great work which is being done on the renewable power side, both wind and solar, the costs of projects and the renewable power coming down, and the volumes increasing ever faster. However, as a chemical company, we're looking also at the molecules. So how do we still produce the materials that we need in the economy of all of us in a decarbonized way? And if we look at the next slide, how we see it is that indeed green hydrogen is a key building block in that enables that decarbonized and circular chemical industry. Because no way how we look at it, we still want our materials, we still want to travel, and I think all of us can relate to how much we miss traveling at these times. But we will get back to that, and we need chemical materials to drive the economy, to drive our lives. Now, green hydrogen is a key enabler in those industries, and obviously, as we all heard, the costs of green hydrogen are not at a level where we can competitively use this hydrogen. So we looked at it from that side, but we'll go to the next slide. We also saw an advantage that we have because we already currently operate 1,000 megawatts of electrolyzers worldwide for over 100 years. So actually, one of our founding companies is the EGA in Scandinavia. So over 100 years, we're operating electrolyzers in different fields. So chlor-alkali, that's actually the electrolyzer behind me, 200 megawatt electrolyzer in Rotterdam. The sodium chlorate, which is strongly related to pulp industry, and even water electrolysis. For over 3 decades, we operate a 10 megawatt water electrolyzer in Norway. So we have the experience. We're also building out our renewable share in our operations, which is currently 50% of our energy consumption is renewable globally. But we're also expanding that number. So go to the next slide. Some activities that we've performed in renewable energy sourcing is to team up with like-minded corporates to form a multi-party corporate PPA together with DSM, Philips, and Google to source directly with wind parks. And obviously that's important when we're discussing green hydrogen, because you want to have a very tangible, as direct as possible connection to the renewable energy sources to really show the renewable value throughout the value chain. So from the wind park or the solar to up to the product that the consumer is off-taking. And then last slide, some examples of projects that we're working on, really to drive the scale of electrolyzers, but also to work on building the market. As I already mentioned before, I think the scale is an important element, but obviously it's how we together with suppliers really move the scale of the market. I think rightly put, if we're going to invest in a 200 megawatt or 250 megawatt project today, it's quite a challenge for suppliers. So what we were doing over the last couple of years, really work together with suppliers in establishing a path towards the 1 gigawatt. And here are some of the projects that we're working on. The 20 megawatt project that is here is a project which will reach FID early next year, where we together with our partner Gasunie in the north of the Netherlands will supply first green hydrogen to OCI BioMCN for renewable methanol production. Also in the north of the Netherlands, we're working with Sky Energy, which is a company that wants to build a biorefinery for sustainable aviation fuels, supplying Royal Dutch Airlines. And that's a project for FID at the end of next year. So that will add a 50 megawatts, so that's a next step in the scale. In the IJmuiden area, we are developing a 100 megawatt project to supply Tata Steel, both for the use of that hydrogen in their iron production facility, but also working together with Tata Steel on carbon capture and utilization project. So how can you use that hydrogen together with the carbon dioxide that they emit for chemical production. And last project is actually where we are neighboring with our Shell colleagues in Rotterdam to deliver or to work on a 250 megawatt project which will deliver the hydrogen into BP's refinery in Rotterdam. So those are the projects that we'll work on. First projects in FID next year to really drive that scale. But I think next to making the technology work and getting the concrete projects, I think what is very important as well is to work on developing the market. And one of the initiatives that we started a couple of years ago with a lot of other parties in the industry is to go for the certification of hydrogen, because ultimately when we promise our customers that it's a green or decarbonized hydrogen, obviously that needs to be shown and needs to be auditable. And for that, we've worked in previous stages of the certified project, and actually early next year a third wave will go really to have a guarantee of origin system in the European Union, which will disclose the origins and carbon footprint of the hydrogen which is delivered to customers. And I think that's a very important mechanism to drive a green hydrogen economy. Thank you.
Thank you, Joost, and a very impressive list of projects that you are involved in. Before we go to the Q&A, I would like to continue with the presentation of Michel. Michel, the floor is all yours.
Thank you, Walter, and very nice presentations, everyone. Congratulations. So next slide, please. I work for the company Cummins, and we are actually a motorist, like an engine company. We've been making engines primarily on the diesel side for about 100 years. And as cleaner regulations come in place and the need to decarbonate and save our planet comes in place, we're looking at alternative powertrains and alternative ways to decarbonize the world. And today what we see in Cummins is invested significantly in hydrogen companies and battery companies as well over the past 3 to 4 years. So I work for the New Power Group of Cummins in the hydrogen production division. And what we see, and everybody knows that most of the hydrogen comes from fossil fuels, basically, and a very small portion identified on the left comes from electricity, electrolysis, basically. But there's a very clear market and there's a growing market to decarbonize what you see on the right: refining, ammonia, transportation, very small needs for hydrogen today. And next slide, please. And that's why the transition from fossil fuel hydrogen to green hydrogen has seen significant tractions, and there's been investments worldwide, lots in Europe actually, that led the pace, and Canada is yet to follow. I'm hearing that the federal strategy on hydrogen will be announced before December 21st, so we're looking forward to see some numbers. But billions of euros invested to develop green hydrogen. Next slide. And that's one answer to the growth question that was answered earlier, that was asked earlier. I mean, there's various scenarios. It's very hard to know how the demand for hydrogen will grow. There's many studies out there, but it really has to do with, is it business as usual? Will electrification pick up? Will green chemicals, will carbon pricing rise to a point where it becomes competitive to produce renewable hydrogen? But clearly all studies point into the same direction, and everybody agrees hydrogen will play a role in the energy transition. So we're scaling up our plans and our programs to develop electrolyzers that will allow us to scale up. Next slide. And I mentioned earlier that Cummins invested in battery electric technologies as well as fuel cell electric. So basically we're technology agnostic, giving us a wide range or a broad portfolio of solutions from diesel to natural gas to electrification with batteries or fuel cells. So we don't see the world as fuel cells against batteries. In fact, we see that fuel cells and batteries work together. And with this, I transit to the production. It's the same thing Jason pointed out earlier. We don't care if it's PEM or alkaline. We don't either, in fact. It's really about what's the lowest cost of solution, how can you get the greenest and the lowest cost molecule. It's all about the total cost of ownership. Next slide. And so over the 70 past years, we've we still manufacture alkaline electrolyzers, but we've transited and we've evolved and we've developed our product portfolio to include pressurized alkaline. And in the past 20 years, so the slide should be showing 20 years of development for the PEM electrolyzer, from very small lab scale product in 2000 to multi-megawatt electrolyzers today, allowing us to scale up our technology. The reason we're invested heavily into the PEM technology is actually all to do with the total cost of ownership and the maturity of the technology. As the technology matures, it's harder and harder to improve on several factors, and we see more potential to improve on the PEM on all fronts, whether it's the CapEx, the efficiency of the system, the installation cost, the maintenance, the pressure, all these factors we can really improve. And today we find that we're already more competitive than our alkaline solution using our PEM. That's the reason for the massive investments we put forward over the past 20 years. Next slide. And one of the visuals, examples of the improvements of our stack technology. On the left, you see an alkaline pressurized stack that we make in Belgium. In fact, I speak a bit of Dutch, but I won't risk it here. But I've lived in Belgium for a few years in the Flemish part. And this is where we make those stacks. They are 75 kilowatt, producing about 35 kilograms of hydrogen per day. And for the same size, we can produce more than 1 ton of hydrogen per day on a single stack. So it's really a complete game changer into stack technology. And also, it's also pressurized at a higher pressure. This delivers hydrogen at 30 bar, whereas we're limited to 25 bar or 10 bar with our previous stack technology. Next slide, please. And in real life, this product has been developed called the HyNetherlands 1000 electrolyzer, which is made in Canada. It's been developed in Canada, but it's also made in Europe because we have a plant in Uvel, not far from, I guess, 30 minutes from Eindhoven or 30 minutes from Antwerp, right in the middle, in fact. And that plant presents significant benefits over our previous technologies in terms of efficiency. Today, we're about 40 to 47 kilowatt hour per kilogram on the stack side, but that technology keeps improving. So a year ago, we were a little bit higher, and the next generation of membranes electrodes will put us again more efficient. So these numbers are probably already obsolete from what we see in the field. This electrolyzer delivers hydrogen at pressure, so we don't need expensive compressors. Sure, you'll need to distribute the hydrogen and pressurize it further, but we save the expensive compression stages. And lastly, we work as well on the front of installation. So installing an electrolyzer is not that simple. You've got big stacks, you've got the gas holders and all these things that we built over time. But we got rid of it by putting it in a compact skid that doesn't require any special installation or any special delivery instructions. So we take significantly less space now. So if you go to the next slide, you'll see that was the rendering, and that's what it looks like in real life. This plant is in operation. In fact, there are 4 electrolyzers like this. It's a 20 megawatt electrolyzer plant consisting of 4 blocks of 5 megawatt. That's a very small square footage. This is about 2.5 meters high, 2 meters wide, and 8 meters long. So it's a very compact 2 tons per day plant. Next slide, please. And there you see it from the other angle. And what it gives is also that you can install these electrolyzers. As you see, there's another one in the back, and there's 2 more in a building that's just a standard building. You don't need any special area classification. You just drop your electrolyzer and commission it there. And while you commission it with your standard laptop and standard tools, you can still work on the second unit. So we facilitate commissioning with these drop-in play blocks. Next one. And that's what we're building now. The plant you've seen is actually the commissioning is almost complete. We're starting the last electrolyzers now. So we're producing more than 5 tons per day using this electrolyzer technology. I cannot show the inside picture until there's an official opening, but you've seen the first and second skids there. So that's a very exciting project we were doing with Air Liquide Canada. It's a liquefaction plant that's been installed in 1985. So we actually supplied an electrolyzer 35 years ago, alkaline atmospheric. And Air Liquide looked at replacing the production technology. So they looked at SMR, which is actually on site already. They have 2 SMR, but they also looked at electrolysis, given the need and the demand for green hydrogen. And they looked at, in terms of all technologies, the lowest total cost of ownership was the technology they selected here. So very promising for the future. And maybe eventually we'll have SOFCs in the portfolio, because that's also very promising electrolysis technology at higher temperature and higher potential efficiency. Next slide. And with this, I close up. Thank you.
For you, you've been in the hydrogen world for a very long time. There was a hype in the beginning of this century where there was a lot of noise around hydrogen cars. At this moment, what do you expect to happen? Is this the next hype, or is this here for the long run?
Well, I stuck that long for that for 20 years. So I joined in that hype, right? As soon as I finished university, it was an exciting opportunity in the electrolysis world with the Belgium group making these electrolyzers. So I joined them. But I think that today is really, and I've served waves, you can call them mood waves, right? So mood swings, maybe. and today where I am, what I see the industry, I'm definitely continuing and focusing and trying to develop more and more of these projects, because there is a role for hydrogen. And I mentioned it's not against batteries, it's with batteries. That's mobility, but there's multiple other roles where it can play a role, whether it's for industry, for green chemicals. It's such a great energy vector. So I find that we're going to the mainstream mode and scaling up, like Joost presented the slides, right? And Afkenel as well. Thank you. And Nicole.
All right, that sounds promising for the future. Joost, a question for you. You're partnering with some wind consortium we've seen in your presentation. As green hydrogen projects are going to be growing bigger and bigger, you probably need to look at other production facilities. What are your options, or what are your preferred options? What are your thoughts on this?
Well, I think we're technology agnostic, I would say. So the earlier projects that we are developing are alkaline based from a technology perspective, but that doesn't mean that will be it for the end of times. I think that in general it's important, and that's where we're also happy to to show the projects that we're developing and learn of the other projects under development. It's important to show also to suppliers basically the future need for equipment, because companies as Cummins will not invest in increasing production capacity if they don't know the market demand will be there, and vice versa. If we don't know what type of technologies are being developed and at what scale those are available, we cannot develop our project. So a lot of this is aligning on growth plans. It's a lot of it is sharing the future pipelines to make sure that both supply and demand for those equipment is being aligned. We do see that the demand in the chemical industry is big, so you can reach these large-scale projects with current installations. So the demand is there. Obviously, the cost parity is not there yet, but at least from a volume perspective, we can grow the projects, and with that, I think we can further the industry to get to the cost levels that we need for a decarbonized economy.
Thank you. Joost, another question for you. Will your work be focusing on the smaller electrolyzers, or are you going for the big ones in the future? There was a question from the audience.
Ultimately, we want to go for big ones, but then again, as a chemical industry, we also want proven technology. So that's always the big challenge that obviously we're facing. But typically, if you look at electrolyzer plants, as an example, the one behind me, is that you have multiple stacks. I think Michel added it as well. So basically, scaling up is adding stacks but a lot of the scale economies come from your balance of plant and from having a big project to reduce the overall project costs, because it's not only the equipment that you have to buy, but you have to buy a factory. So in that sense, I don't think there's a you have to choose for big electrolyzers stacks as such. You will add those stacks, but you will definitely increase scale when it comes to cleaning, gas liquid separation, electrical equipment, quite important cost element as well. So there you will see the scale increasing. I don't think that we will need to have that on the stack level in such a way that we will have it on the rest of the plants.
Thank you, Joost. I would like to go to some of the questions that we got for the entire group, or for the previous speakers. First of all, Nicole, there was a question for you. In Netherlands, a big network of the gas pipelines. Are you working to integrate Europe in that international network of pipes?
Yeah, that's a good question. So I think that would definitely be the intent in future. But we go step by step. So first we're looking in the Netherlands right now. But for example, North H2, we would be looking in the next step indeed in Germany, and who knows what after. Yes.
Thank you. A lot of steps to take from here on, I assume.
Yes.
Michel, a question for you. Are there any lessons that you have learned or could learn from the other corporates such as Shell, ENGIE, and Nouryon?
Well, the company I'm mostly familiar with, I know them all obviously, but the first, one of the pioneers was Shell, with the Shell hydrogen division in the past. So we've worked closely together and developed some project with them in the US, the first fueling stations and so on. So we need people like that, companies that drive the market somewhere. And I think right now we're in a phase of consolidation. So companies like ENGIE, Shell, and others are now looking for partners and EPC companies to work with and try to get to the scale that we need to develop lower cost solution and get the molecule more competitive.
Anyone else wants to comment on that? And if not, I go to the next question. I have another one for Jason. Jason, if we would give you 100 million at this moment to invest in the hydrogen supply chain, where does your money go to?
Oh, I think as I caveated this earlier, I think we're far less knowledgeable about this space than some of the other panelists. So I think I would defer to some of them with with the answer to that question. I certainly wouldn't make 100 bets in of $1 million each in seed stage companies. That certainly wouldn't spray and pray, but maybe allocate a small fraction of that for some selected seed stage investments.
Are there enough seed stage investments to go around with 100 million?
No, that's why I'd say I'd only carve out maybe a quarter of that or less for for seed stage opportunities. Certainly 100 million is I think you would not want to place that many bets. There are probably not enough quality opportunities at that stage anyway.
Thank you. Afkenel, when will we have green hydrogen at a competitive price, you think?
I'm getting all the difficult questions today.
You're lucky today, yeah.
Yeah, I think there have to be some developments on the technological side, obviously also on the off-taker side, and probably the competition of gray hydrogen, so hydrogen made from natural gas, has to have a price increase either through CO2 pricing or taxes, but there has to be at a certain point a sort of parity between the two, and then it's going to be much easier. But you know, I had a big wish list, so there's still some way to go.
You had a very big wait list there. Joost, what are the connections between Nouryon, green hydrogen, and California, Canada?
Well, as Nouryon, we're a global company, so we're active in the US with our sodium chlorate electrolyzers. I don't think we're yet active in California, but obviously, I think an opportunity is where I think globally, I think where hydrogen or renewable energy is available at large scale. Where you will have a favorable regulatory regime. That is typically where we could operate. We focus really on the chemical application. So where I think California, as I understand it now, is the main drive is on mobility. We really look at opportunities in chemical industry.
Thank you, Joost. One last question before we end this session, and that question is for Nicole. It's a very short question, by the way. Are you a member of the Women in Energy group?
Yes, I am. Yes.
That's good.
It's a good initiative, indeed.
And useful?
I think so, yes.
All right. That brings us to the end of this session. The next session will continue in the Zoom call. The link for the Zoom call is in the MentorJam platform, and we will be discussing next steps for the Netherlands, Canada, and the US, California in green hydrogen. With that, I would very much like to thank the 5 panel members. Thank you very much for joining us today, and thank you very much for your impressive presentations. And looking forward to seeing you and talking to you in the future. So thanks again.